Hi, my name is Christos Karamolegkos. I am the system administrator of GFOSS, and I will present to you the installation of Matrix and Jitsi home server we did to meet the increased communication needs caused by the current global health crisis, the lockdowns and remote working that became necessary for the above reasons. So, in spring, we had already understood that there was a need that existed and continues and will continue to exist for remote work and therefore communication. Before the pandemic, our work environment was as it was usual in the same place. So the communication was direct, instant, easy and natural. We realized things were changing and the conditions would change as well. And we started looking for alternatives that would support the immediate, this instant, easy and natural communication that we were used to. So, out of those that we evaluated, Matrix stood out, which in collaboration with the Element client offers a modern environment, both through the web and in native applications for all standard operating systems, desktop and mobile devices. At the same time, Jitsi offers the possibility of group teleconferencing, and this creates a complete solution for instant messaging, file sharing, video and audio calls, and with 2 or even more participants. Another reason we chose Matrix, as we will see in more detail, is the support it offers for integration and collaboration with other communication platforms. In a company with many external partners, each of whom wants to use the platform he has chosen to communicate with you, it is a lifesaver to be able to keep your open conversation organized, something that is practically impossible when you have to use Slack and Skype and Messenger and Google Hangouts and whatever else service your partners want to use. So, today's presentation is the product of the technical know-how gained from the experience of installing Matrix and Jitsi and using it productively as our main means of communication, both within the GFOSS team and with external partners. These are the contents of the presentation we're going to see. So let's get started with introduction and get familiar with Matrix and Jitsi. So what is Matrix? Matrix is an open standard, an interoperable, decentralized and secure real-time communication standard. It is an open standard because in the form of Matrix specification and under the supervision of the Matrix.org Foundation, a non-profit company set up to act as a neutral and independent custodian of Matrix template on the behalf of the whole community. It is interoperable as it provides the public with fully documented interfaces, and it can be used to connect and operate with other systems. Interoperability is especially important in IT because there are countless systems and standards that are constantly changing, evolving, popping up at any time. So it is crucial that they interact smoothly with each other. It is decentralized, which means that there is no central data storage point. Everyone can host their own server and have control over their data. And the really strong point of Matrix, however, is that each home server can communicate with the others. So the user can interact with users on different servers than his own without violating his privacy. Of course, it is real time because you can communicate instantly, and thus it's ideal for building systems that require instant data exchange, such as instant messaging. And finally, it's secure. It provides peer-to-peer encryption. And this means that each message is encrypted on the sender's device or client and is decrypted only on the recipient device or client without any immediate decryption or reading on the server. So what is the purpose of Matrix, the mission? Its initial goal is to fix the problem of fragmented IP communications, meaning it allows users to send messages and call each other without having to worry about what application the other user is using, making it as easy as sending an email. In the long term, the goal for Matrix is to function as a universal messaging system for HTTP and general data synchronization and communication, allowing individual services and devices to easily communicate with each other. And ultimately, Matrix aims to provide an ecosystem similar to that of the email, which means that using a neutral identity provider system, just like an email address or a phone number, you can find people to talk to. So, to help create new implementation, Matrix provides multiple open source reference implementations, and these range from Matrix compatible home servers to SDKs for client applications and services. Systems that implement and use Matrix as a communication protocol can be used for instant messaging, VoIP, WebRTC, Internet of Things, and wherever a standard HTTP API is needed, like posting and subscribing to data or feeds. Let's get a quick introduction to Jitsi as well. Jitsi is a collection of open source projects that allow easy teleconferencing. The main application of Jitsi are Jitsi Video Bridge and Jitsi Meet, which allow the teleconferencing to take place, and while there are other applications that provide even more functionalities, such as audio, dial-in via SIP, recording and simultaneous streaming, and anything else. So Jitsi is a favorite video conference solution for those with privacy issues, like journalists, for example, or residents of countries with limited freedom of speech on the internet. And it's worth mentioning that the word is supported, used, and recommended by privacy advocates such as Edward Snowden. So, we can see here the architecture of a standard Jitsi installation. As you can see, there are various components, but the main ones are, how shall I say, there's a web server that acts as the portal of the user to connect to the system, and Jitsi Meet, as we already said, is the main application, along with Jitsi Video Bridge that help create the teleconferencing. So now let's get to an example of how does Matrix work. Okay, so a moment please. Here we can see 3 home servers. Each home server has one user, and they all participate in the same room, which is synchronized between the 3 home servers. Alice, the user of the first home server, as we can see, sends a message to the room in her home server. The home server adds the message to her room's graph of history. The message will be linked to the most recent messages, which had node links at this point, and the home server will sign the message, including the signatures of the messages to which it was linked, so that the history cannot be tampered with. The home server will send the signed message over HTTPS to all the other home servers which are participating in the room. Now, each of the home servers that receive the signed message does a series of checks. First, they check the signature of the message to avoid tampering with the history, as we said. Then they check that the HTTP request signature, they check the signature to avoid sending the sender identity, and they validate whether the sender's historical permissions allow them to send this message. If the message passes these checks, it is added to the recipient's history graph. Finally, the users connected to the other home servers, the recipient ones, receive Alice's message. Now, Bob sends a response to Alice's message. Bob's home server adds his message to his own room's history graph and links it to the most recent unlinked one, namely Alice's message. Meanwhile, Charlie also responds to Alice's message, erasing the message sent from Bob without knowing about it yet. At this point, the three home servers each have their own version of the room history. Fortunately, Matrix is designed to deal with such inconsistencies. Bob's message is related to Alice's and Charlie's home servers, and after the checks pass, it is accepted. In the current situation, Bob and Alice are in sync. We can see that they have the same history graph in their rooms. But Charlie's home server, there's a problem. The history seems to be split. So the client that Charlie uses will be notified of Bob's message and may decide however it chooses to handle the event. Charlie's home server will forward the message to the other two, and once they accept it and include it in their history, they will be in sync again. So now everyone has received all the messages, and there is a consistent view of history between all the participating home servers, but still the history is split. So later on, Alice sends another message. Her home server adds it to its history and links it to the most recent unlinked messages. That means that her message will be linked to both Bob and Charlie's messages, effectively merging the split in history. So after Alice's message is transmitted to the other home servers in the room, they accept it, and thus ensuring the eventual consistency and integrity of the distributed room history. So now let's see some features of Matrix. A great feature is bridges. As we talked about earlier, you can communicate, because Matrix is interoperable, you can use it to connect with users using other services. So these are some services that are supported. This is not an exhaustive list, as there are new bridges that developed every day and anyone can do so. You can use the Telegram bridge to talk with the user on Telegram example without leaving your Matrix client. Then we have widgets. Widgets require an integration manager to work, such as dimension, and they work by adding an iframe to the client, so you can connect to a Jitsi conference and participate in a teleconference with more than 2 participants. You can watch YouTube videos, you can play Spotify music, you can collaborate with editing public Google Docs, and pretty much any website that supports embedded can be added as an iframe in the client, so anyone in the room can see it. And the final feature I want to talk about is bots. Bots are virtual users who post automated messages in response to commands given to them. So you can develop or use an existing bot and subscribe to feeds, and there are some bots that are personal assistants and management tools. You can watch GitHub or GitLab pipelines, create polls, have reminders sent to you, even watch comics on, or really anything else. As I pointed out earlier, this is not an exhaustive list. There are many bots you can use. And so let's talk about our installation at this point. The installation we created at GFOSS is used productively for a couple months now. Let's see the necessary components. Matrix is extremely modular, so you can use only the components you need, but you need at least the following ones. The Synapse home server. Synapse is the reference home server of Matrix. There's another home server in the making, Dendrite, which is written in Go, and it's supposed to be much faster, but and less resource heavy, but is not yet out of alpha pre-beta phase, so it can't be used productively yet. And next you need a database for storing the data of the home server. You need a co-turn server, a stan and turn server for audio and video calls via WebRTC, and of course you need a certificate for the HTTPS. And the work environment, the Matrix client, as we said, the most popular one and the one that offers the most functionality is Element. The Matrix identity server, you can either use Sident, which is the reference identity server, or the most advanced one, Mazed. And this is used to find other users to talk to. And you need a mail server. Through all Matrix services, send outgoing emails. And finally, as we talked, the web server, which stands in front of all the other services. We use the virtual machine hosted on Okeanos Knossos, equipped with 8 CPU cores, 8 gigs of RAM, 100 gigs of storage, and Debian 10 operating system. Also, we have connected our installation to our LDAP server, so our users can just access the service without having to re-register. They can simply log in with the credentials they already have. So, if at first we tried to install it manually, and that had many disadvantages. There are many and complicated installation steps. There is a difficulty to update the services because each application is different and something might break in the process. And it's against the practice of infrastructure as code. So we try to find another way, and thankfully there is one. We installed finally using Ansible and inside Docker containers. There's a very well maintained Ansible playbook called Matrix Docker Ansible Deploy, and it automates the installation process, so it's very easy to set up, it's very easy to update, and it serves very well the purpose of infrastructure as code by maintaining the settings in YAML files. We host them on our private Git server, so we can see what changed when, and if there is a problem, we can immediately undo the changes. And each application is stored within a Docker container, so we isolate it from the host system. It offers a predictable and stable environment, and it's very easy to migrate to another host if we ever need to. So, why we chose Matrix? And I will tell you a couple of reasons. First of all, it's the maturity and the acceptance of the project. Although it came out of beta phase in 2019, it already has millions of users. These include individuals, businesses, companies, organizations such as Mozilla, and even whole governments, such as the French one. Specifically, as early as 2018, the French government created a fork of the Element client and uses Matrix to communicate for encrypted communication between its members and services. And this is very good news that a government supports open source and privacy. At the same time, home servers and clients receive updates and are constantly evolving, so they're constantly adding features, solving problems, and this provides a very well ecosystem to be part of. And then we can see that they are defending privacy. A very recent issue is serves as evidence to that. So what happened? Governments are asking communication applications to add vulnerabilities to their encryption in order to be able to provide them with data of their users upon request. About 2 months ago, on October 11th, the United States, Canada, Japan, India, Australia, and New Zealand issued a statement urging technology companies to work with them and the aforementioned call to create backdoors in their applications. The reasoning was that this would help predict and deal with terrorist attacks, child abuse, fascism, and other unaccepted behaviors. And about 1 month ago, on November 9th, it became known that the European Union is also preparing such measures for a vote, which, if approved, will become the basis for the creation of relevant legislation. So, the Matrix Foundation published a response article, immediately updated on November 9th, which shows that they are following the developments with interest. The article states that introducing vulnerabilities in the system is wrong, because sooner or later they will be exploited by malicious users, and the encryption benefits the whole community, and even if the absence of it harms the 0.1% of malicious users, those users will just move to another platform that offers secure encryption, and the remaining 99.9% of innocent users will remain exposed. Thus, not only do they decide to not comply with such requirements, but they prepared their own counter proposal, which concerns the strengthening of the moderation that each server owner. We're going to talk about our conclusions and our next goals. So right now, after using Matrix productively over the last couple of months, as I said, we wanted to further increase our privacy and the ownership of our data. So we have an installation of Nextcloud in progress. Nextcloud offers the solutions to the following problems. First of all, document sharing and even general file sharing, collaborating on documents, editing and sharing with partners, email management, calendar, GitLab integrations. It can be connected to external storage spaces. But an important bit is that there is an element client plugin so that we connect to the already established infrastructure that we have in place. And we can see no one can spy on you if you are the one who maintains the server. And with peer-to-peer encryption, even I, as a server maintainer, can't see what the users are transmitting. So if you want an open source privacy protection and your absolute data management, while collaborating, organizing your data, and whatever else you can do on commercial platforms, you can do it yourself with relatively slow cost. And this is what we opted for. So that was all. I hope I didn't bore you with the technical details of some points. I tried to appeal to both technical and not so much audience. If there are any questions I'm willing to answer, you can always reach out directly to me on my email. You can see it here.
Thank you, Christos. We have like around 4 minutes to take some questions. I would think that the GitHub repo that you linked on your presentation with the guides for installation using Docker and an Ansible would be useful. So maybe you can share that link to the chat.
Yeah, it's actually a very well documented playbook. So let me see if I can copy from here, or no, I probably can't, but I will share it in a moment. Yeah.
And I had one question actually. Like you mentioned that you've been using Matrix and Jitsi for the last months, also pushed by the Corona situation. Did you migrate from another system, or was this your first?
Currently, we inside the GFOSS team, we use Google applications. This is what we are trying to migrate to Nextcloud from. Mm-hmm. So a good portion of the internal communication was via either emails or Google Hangouts. But as I said, the communication with internal partners was with any different platform that they wanted to use. Sorry, I'm looking away, but I'm trying to find the link. So anyone wanted to use their own platform, and we effectively had to use what they wanted. So with Matrix, we didn't just migrate, we were able to unify our communications, and there's a consistency now. We can use the same client to communicate with anyone.
Thank you. Great. Good luck with the remaining work on Nextcloud migration.
Thank you very much. I shared the link, as you can see. Is there any other questions?
Any other questions from other people? Like, we have around 1 minute, but still we can continue answering on the chat.
I see a question, can Nextcloud authenticate with LDAP? So yeah, of course it can. And you can, first of all, you can authenticate with LDAP. You can even use some single sign-on protocols. So it's, yeah, as it's mentioned, like OAuth and SAML. So you can use those as well, but even more, you can sign in to your matrix in the element client in the plugin. So once you log in to your Nextcloud infrastructure, you are already logged in your chat application as well.
Great. Thank you. Okay. Thank you, Christos. We are done with the presentation, and now.
Thank you very much.
Thank you.